Hello students, this is El-Refaei math teacher for both AS and A2 level. Today we're going to continue talking about chapter 3 trigonometric 3.3 double angle formula. I'm going to explain to you today how we get the double angle formula from the compound angles, and we're going to apply some questions related to the double angle formula. Let's start with the compound angle formula. Sine A plus B equals sine A cosine B plus sine B cosine A. I'm going to switch B and write it as an A. So sine A plus A, I will have 2A, the double angle. According to that, I will have sine A cosine A plus sine A cosine A. And because these two terms, they are the same, I'm going to write 2 sine A cosine A. Let's move to the subtraction case. I'm going to switch B to be A. So sine A minus sine A, sine A minus A equals sine 0, and sine 0 equals 0. So I don't need this. Cosine A plus B. It's cosine A cosine B minus sine A sine B. As I said, I'm going to switch B to be A. So I'm talking about cosine A plus A, which is cosine 2A. It will be cosine A plus minus sine A sine A. Cosine by cosine, it would be cosine square A minus sine square A. Some students will say, can I switch sine A and write it 1 minus cosine square? Let's do it. Cosine square A minus sine square A, it's 1 minus cosine square A. I'm going to expand the negative sign. Cosine square A minus 1 plus cosine square A. Cosine square plus cosine square, it will be 2 cosine square A minus 1. Alternative form for the double angle formula in the cosine case, for the cosine case. Some students said, okay, I'm going to switch cosine square to be 1 minus sine square. Can I do that? Let's do it. 1 minus sine square A minus sine square A. So minus sine square, I'm talking about 1 minus 2 sine square A, another form. So cosine 2A, I have 3 forms. The first one, cosine square minus sine square. The second one, 2 cosine square A minus 1. The third one, 1 minus 2 sine square A. Let's do the subtraction case. I'm going to switch and write A instead of B. Cos A minus A, I will have cos 0, and cos 0 always 1, so I don't need this case. Let's continue to the tan case. So instead of B, I'm going to write A. Tan A plus A, tan 2A equals tan A plus tan A over 1 minus tan A by tan A. So it will be 2 tan A over 1 minus tan square A. Let's move to the subtraction case. tan a minus a, tan 0, and tan 0 equals 0. I don't need this case. So according to that, I will have three cases for double angles. 1 for sine, 3 for cosine, 3 alternative forms, and 1 for tan. I'm going to move for further questions related to the double angle formats. Question number 1. Given that sine A equals 5 over 7 and A between 0 and 90, it means the first quadrant, find the value of sine 2A, cosine 2A, tan 2A. As I said before, I'm going to draw a right angle triangle. This is the angle A. Sine is opposite over hypotenuse, 5 and 7. I need to find the value of x. 7 squared equals x squared plus 5 squared. 49 minus 25 equals x squared. So 24 equals x squared. Root square for both sides. X equals 2 root square 6. Use the calculator, and the calculator will give you 2 root 6 because 24 it's 4 by 6, and root square of 4 is a 2. So x equals, and because I'm talking about sides length, will be 2 root square of 6. Let's revise. Sine A, 5 over 7. Cosine A, 2 root 6 over 7. Tan A equals 5 over 2 root square 6. Let's move. Part A. Sine 2A equals 2 sine A cosine A, which equals 2 by 5 over 7 by 2 root 6 over 7, which equals 4 by 2, 10, by 2, 20, root 6 over 49. Part B. Sine, cosine 2a. I have 3 forms for cosine 2a. If you choose any one of them, you're going to get the same answer as the other two. For example, I'm going to use cosine square a minus sine square a. Cosine square a, it's 2 root 6 over 7, all of it square, minus 5 over 7, all of it squared, which equals 24 over 25 minus 24 over 49 minus 25 over 49, which equals negative 1 over 49. Another 4. 1 minus 2 sine square a. 1 minus 2 by 5 over 7 squared, which equals 1 minus 22, 5 is 25, 5 squared, 25 by 2, it will be 50. 50 over 49, 1 is 49 over 49, which equals negative 1 over 49. Okay, let's move for tan 2a. Part C, tan 2a equals 2 tan A over 1 minus tan square A. It's 2 by 5 over 2 root 6 divided by 1 minus 5 over 2 root 6 squared. Let's use the calculator. 2 times 5 over 2 square root 6 divided by 1 minus 5 over 2 root square 6 squared, which equals negative 20 root square of 6. I hope question number 1 is easy and clear to be applied. Let's move to question number 2. A past paper question. Solve the equation sine theta equals 2 cosine 2 theta plus 1. Solving all solutions in the interval with theta more than or equal 0, less than or equal 360. Now, as I said before, I have sine and cosine, so I can't solve it because both of them having different angle size, theta and 2 theta. So I have to switch cosine. Which one of the 3 forms I have to use? Because I can convert this to be quadratic by using cosine 2 theta equals 1 minus 2 sine square theta. I'm going to use this form for 2 reasons. Instead of 2 theta, I will have theta, and also I have sine and sine squared. So I can convert it to be quadratic. So sine theta equals 2 open bracket 1 minus 2 sine squared theta plus 1. Sine theta equals 2 minus 4 sine squared theta plus 1. Move all the terms on the right side to be on the left side. 4 sine squared theta plus sine theta minus 3 equals 0. I'm going to factorize this. You can switch sine to be u. Sine theta to be u. It's easier to understand that you have a quadratic equation. 4u squared plus u minus 3 equals 0. And use general formula or factorization. 4u minus 1, and I have plus 3 here. You can check. No, it's incorrect. So I'm going to switch between 3 and negative 1. So I will have plus 1 and minus 3. Let's say negative 3 plus 1. I have 1 here. So it's correct. 4u minus 3 equals 0. U equals 3 over 4. U plus 1 equals 0. U equals negative 1. U is actually sine theta. Sine theta equals 3 over 4. And I have a positive answer. And sine positive first and second quadrants. So sine inverse 3 over 4. And my answers should be in the degree form. I have to check that I have a degree. Yes, it's degree. Shift. Sine 3 over 4 equals 48 48.59. Cambridge system, the angle 1 decimal place, it will be 48.6. This is the first, so theta 1, first quadrant, 48.9. The second will be 180 minus 48.59. Okay, so I'm going to use the word answer. 180 minus answer, it will be 131.4. 131.4 degrees. Okay, so sine theta equals 3/4. I have two values. Let's move to the second solution. U equals -1. Sine theta equals -1. Sine theta -1. So theta, it will be 270. I hope this question is clear. You can repeat it by yourself for the second time and check, are you going to get the same answers or no? Let's move to question number 3. Pause the video for 5 minutes, try to solve it, and then come back. Check your answers with my answers. Pause the video and then come back. Question 3. Solve the equation 2 cos x minus cos 1/2x equals 1, where x more than or equal 0, less than or equal to 1. Many students confused because they haven't seen before 1/2x and x in the same equation. So I'm going to rename 1/2x as an a. So according to that, x will be 2a. 2 cos 2a minus cos a equals 1, where x, which is 2a, is more than or equal 0, less than or equal to 5. According to that, a will be more than or equal 0, less than or equal 5, because I'm going to divide each part by 2. Now, I have 3 forms for cos 2a. Which one of them I'm going to use? I'm going to use 2 cos square a minus 1, because I need to convert it to be quadratic, and quadratic having one trigonometric ratio, which is cos a. So 2 open bracket 2 cos square a minus 1 minus cos a equals 1. Expand 2 4 cos square a minus 2 minus cos a minus 1 equals 0. Simplify 4 cos square a minus cos a minus 3 equals 0. I'm going to rename cos a as a u. So I will have 4 u squared minus u minus 3 equals 0. And then I'm going to factorize it. 4 u negative 1 here and plus 3 the other side. Okay, so the first one, 4 u plus 3 equals 0, u equal negative 3 over 4, u is cos a, which equals negative 3 over 4, only cos inverse 3 over 4. I always find the inverse for a positive. Okay, I have to check that I'm dealing with rod, shift, mode, 4, shift, cos 3 over 4, which equal, I want to be 0.7227. I'm talking about A, first quadrant. A should be second because I have negative 3 over 4. So 0.7227 pi minus 0.7227 to convert it to be in the second shift. Pi minus answer, it will be 2.4185. This is A, and A, it's 1 over 2x. So I'm talking about x. The actual interval is x. So I'm going to multiply 2 by 0 by 2.41885. So 2 times 2.41885. Answer times 2, which equals the three significant figures 4.84. The second solution, u minus 1 equals 0, u equals 1. So I'm talking about cos A equals 1, cos A equals 1 at 0, so A equals 0. This is 1 over 2x, so x equals also 0. I hope it's clear. Let's move to the last one. Show all necessary working, solve the equation cot 2 theta equals 2 tan theta for theta more than 0, less than 180. I'm going to rewrite cot 2 theta as 1 over tan 2 theta equals 2 tan theta. And as you know, tan 2 theta equals 2 tan theta over 1 minus tan square theta. When I say 1 over tan 2 theta, I flip the left side, so I have to flip the right side. It would be 1 minus tan square theta over 2 tan theta. So 1 over tan 2 theta, it will be 1 minus tan square theta over 2 tan theta equals 2 tan theta over 1. I'm going to do a cross multiplication. 1 minus tan 2 theta equals 4 tan square theta. Move tan square to the other side. So I will have 5 tan square theta equals 1. So tan square theta equals 1 over 5. So tan theta will be plus minus root square 1 over 5. Okay, tan inverse root square 1 over 5. And I have to check that my calculator in the degree form. Check move, shift, move, three, shift, tan, root square 1 over 5, which equals 24.09, around to be 24.1. I'm talking about the first and the second, my interval, first and second. The first will be positive, second will be negative. So the angle for the first quadrant, it's a positive. For the second quadrant, for the negative, because I'm talking about the root square of 1 over 5, positive or negative. So I'm talking the first quadrant in the positive case and the second quadrant for the negative case. The second quadrant, 180 minus 24.09, around to be 180 minus answer. It will be around to be 155.9 to 1 decimal place. Cambridge, the angles should be 1 decimal place. So this is the first angle, positive case. This is the second angle for the negative case. I hope your today class is clear. Please share and subscribe. If you have any notes, write in the comments. Solve more questions from your math notebook. If you have a classified question, solve them too. See you in another class. See you then.